Okay, welcome back after a long time. Uh, Sorry for the delay actually. We are going through our semester examination. That's why we are in a little bit delay. Okay, so you are watching Chemicals as you know already. So in this segment of video lecture, I'll start a new topic, molecular symmetry and group theory. Okay, and it's a very introductory video. It will be very small also. In this segment, I will discuss about symmetry and the symmetry elements, symmetry operation like that. And as the lecture goes on, you will very much hearing one word like symmetry, symmetry, and symmetry. So what basically symmetry? Symmetry is actually our nature is nature is full of symmetry. Okay, symmetry means actually in a molecule or like in whatever you are seeing, there is a very good pattern. Okay, that pattern we are finding, and based upon that pattern we are trying to classify our daily objects or like molecules. As we are chemists, we talk about molecules. Okay, so with this, okay, and symmetry actually contains two terms. Okay, every time you hear symmetry, it contains two terms. Like what is this? One is symmetry elements, and another one is symmetry operation. So these two is our topics today. So what is symmetry elements? In every book you will get a very long definition of symmetry elements, but I just want to say a molecule which actually a molecule possessing which things, the molecule possessing the things that are called symmetry elements. Like a molecule has, suppose a molecule is getting its indistinguishable form after rotating some amount of angle. Okay, so that thing is inherent in that molecule. So this is one of its symmetry elements. Or like a molecule is possessing a plane and which is dividing molecule to a mirror symmetry element. Okay, so that's the thing. So molecule is possessing things that are elements, and to find out the symmetry elements, what we have to actually do, the action we have to take, that thing is symmetry operation. Just like to find a C, I will discuss what is CN or SN. So I'm just giving an example. So to find a CN, what we have to do, we have to rotate it around that 360 degree in whatever. So the action we are taking to find out the symmetry elements, to find out the indistinguishable form of that molecule or that object, that thing is symmetry operation. Okay, so I'm just pointing out. Sorry. It is action taken to find out the symmetry. Okay, so what are the main symmetry elements that may possess any molecular object? What are the symmetry elements? Actually, there are sometimes 4 or 5. Okay, one is identity, 2 is proper axis of symmetry, proper axis of symmetry, 3 is plane of symmetry. Sorry. In a smaller notation, it actually will not say every time proper axis of symmetry like that. We'll just denote it using Cn, and this is a sigma. Sometimes say POS, a plane of symmetry, a sort of notation is this. And there are improper, or in other words, like alternate axis of symmetry. And Okay. Oh, one more thing. That is center of inversion. Okay. So let me see. First thing. Okay, we will do the first one. What is this? Identity. Basically, identity means doing nothing. And you need to know one thing that is in this universe, every molecule or every object has this symmetry of also, that is identity. So identity means doing nothing. So let me take on just whatever you want to take, like this thing. After doing identity operation, this will be like same. Whatever, if you number this, again this will be same. So this is my identity. Identity is doing nothing. And the thing I told you, every molecule possesses identity, whatever. And the two, that is Cn. I'm not writing the proper axis of symmetry, it says just Cn. So what Cn means actually? So a molecule is said to possess a proper axis of symmetry Cn if after rotating angle theta is 360 degree by n, if after rotating this amount of angle, the molecule again come back to indistinguishable form, which is first indistinguishable form with the first one. Okay, then it will say as Cn. So let me take one example that will clarify you. Example, you know, water molecule. Okay, water is like that, planar molecule. So if you see, like I'm taking this C2. Okay, let me just think this is your C2, and after just rotate it 180 degree, theta 180 degree. So you will be your 2. After rotating 180 degree, it will become like same. If you number it 1 or 2, then after 180 degree rotation, it will become just H will change its position, but the molecule remains same. So this molecule possesses a proper axis of symmetry C2. Okay, you can take many more examples. There are a lot of examples actually. You just take, let me give you one more example, like H, Cl, and Cl. So this is a tetrahedral compound, you know, CHCl3 chloroform. Okay, but this molecule is actually possessive. Just see very carefully. If you think of an axis which is going through this, okay, this axis. So now see this molecule, whatever amount your angle is, whatever amount in angle you are rotating it, this H is not going to change. So you have to now think of in which amount of your rotating this 3-chlorine is changing its position, and it will give you a one indistinguishable form. Okay, so just think of it. And one more thing I need to say, in this case, symmetry elements, you need to visualize a lot more. Okay, in 3D you have to actually compare. Like you just show like 3, and your H is like this. So if you rotate it with 120 degree, that is your axis will be C3, then it will again become, the Cl will change its position, but the form you will get, it will be indistinguishable from the first form. Okay, so this molecule is possessing C3. Like this, any benzene molecule, it will possess one C6, and much more to there. Okay, so this is my Cn, this is proper axis of symmetry Cn. And the second thing, the most important thing is my POS. Okay, sigma. I'm changing the order a bit. It doesn't matter actually. POS, sigma. So plane of symmetry. What plane of symmetry means? In terms of actually, let me take one example that will clarify you more. So let me take one example. Okay, again voice 2. I can take it. So this molecule will said to possess a sigma if you take the sigma as a mirror, then the two part the sigma is dividing the molecule into will be mirror image to each other. Okay. So how? If you take a mirror like this, okay. So just see, if this is a mirror, this is my hand is a mirror, okay. So then this H will reflect to this, and O will not, but this H will reflect to this. In other words, this H will reflect to this. So this molecule is possessing a sigma plane of symmetry. So sigma plane of symmetry, what is the plane of symmetry? If plane of symmetry is a symmetry element which divides the molecule into two parts in a relationship, like one part will be mirror image to other. That is one plane of symmetry. Let me take one or two examples more. This thing also between two bonds, between the middle point of two opposite bonds. There will be like 2, 3 sigma, and again between two midpoint of the bond there is 1, and like 2 or 3 like this. Okay. And so this molecule is possessing 6 plane of symmetry. There are much more examples. You can go through any of book, like any organic book like Bowie or Mishler and Tarr. You will find a lot more examples. You need to practice this thing to find out what symmetry element is actually possessing any molecule. So this is my plane of symmetry. The third thing is 1, 2, 3, 4. Sorry, actually 4. Inversion, center of inversion, whatever. So, what is the center of inversion? It is denoted by I. What center of inversion is? Center of inversion is a point actually in the molecule. If you join any atom to that point and elongate it to its opposite thing, and it will, if it reaches the same atom again, then this center is said to be an inversion center. I know it sounds like a bit tough, but if I take an example, it will be very clear too. Like what I said. Okay. I'm just taking this fine waveform to see. This is actually the molecule is in plane. These two are outward and these two things are backward. So if I take this, so what I told you earlier, it will be a point like this point. Okay? So if I take any atom and join this, and then if I extrapolate it to its opposite end, and if it reach the same molecule, same atom actually, sorry, this is H and this is H, then this center is said to be an inversion center. And you need to think that not in if it is AF and it is CL, then actually inversion center is reaching you to every opposite point to its same atom. Like here also, if you take Cl and go to this Cl, so here every point is actually opposite every carbon atom is same. That's why molecule is possessing an I. So if you just take this thing, okay? Again, I'm saying in the same framework, I'm just showing you one more thing. Like, this is H and this is H, okay? And this is F, this is Cl. So is this molecule possessing an I? If you take H and go to this, yes, this is an H. But if you take F, and you will reaching actually Cl. So this molecule is not possessing any center of inversion. You need to go through this symmetry operation for each and every point, and you have to reach the same atom in each case. As here, you are going to get H to H, Cl to Cl, but here no. This is F, this is Cl. So this molecule is not possessing any center of inversion. Okay. You can actually design of any one example now. So like if you take this thing, okay, let it be any, let it be any. This is H, this is H, this is Cl, this is Cl, this is F, this is F. So now let's see, this molecule is possessing any inversion center of inversion or not. Now I'm taking Cl. I'm going to matching Cl. Just taking this and matching this. Just taking this and matching this. So this molecule is having a I. So there's no problem into this thing. Now one more symmetry element that left, that is find alternate improper also. So what does that actually mean? Improper axis of symmetry or alternate axis of symmetry, up to which the fourth thing, there is only one symmetry operation to find out this symmetry elements like on Cn or sigma or I. You just need to go through one symmetry action, and you will get, if you get the indexing uniform, then you are easier to say that this your molecule is possessing Cn or sigma or I. But in this case, what does that mean actually? This is denoted by Sn. What Sn does mean? Sn means actually Sn is comprised of two symmetry actions. One is Cn and another one is sigma. And sigma is perpendicular to that Cn. So if a molecule, after rotating a certain theta, that is 60 by n, and then if you take reflection with perpendicular, a mirror plane perpendicular to Cn, and if you get any indistributional form, then you are said to then you can say that your molecule is possessing your Sn axis. Okay, Sn or improper axis of symmetry. So let me take one example. To be a clear example is BCl3. You know BCl3 is a planar molecule. If you think of it, BCl3 is like this two, and there is one more. So BCl3 is a planar molecule, and you know it is possessing a Cn, C3. If you just rotate it 120, this thing will come this, this thing will come this, this thing will come this. So it is possessing S3. Now I want to check is the molecule is possessing any Sn or not. So let me just draw 1, 2, 3. Now after C3, what will happen? If this thing goes this. So actually one is coming here, 2 here, 3 here. Now I have to take one perpendicular mirror to C3. So if I take this thing like here, if I take this thing, just need to imagine what I said earlier. In this case you need to imagine a lot, and that also in 3D space. So after C3 I get 1 BCl. If I take a mirror this, the BCl3 like this, and here one mirror is. Again you will get BCl3. So this molecule is possessing S3. So okay, I think I've discussed all the symmetry axes. So in the next segment of video, I will discuss how to actually classify your molecules into some definitive point groups according to the symmetry elements. You need to at first you need to find out the symmetry elements, and you need to classify it to the according point group. Okay. So I think that's enough for today. Okay. Thank you.